open your book to page 43, we are starting lesson 3.3 called Compound Inequalities. So we're still dealing with inequalities, it's just a little bit more complex or complicated this time. So first we're going to start by graphing compound inequalities, and then later on we'll get into solving them. If we're looking at this table, the first two rows have been done for us. All numbers from 3 to 8 inclusive. So some possible solutions or answers are 4, 5, 6, 3.5, 7.9, 8, etc. All the numbers between 3 and 8. So if we're looking at the inequality, this is x must be greater than or equal to 3, and x must also be less than or equal to 8. This inequality could also be written a different way as one big compound inequality. So I'm going to put x in the middle. X had to be greater than or equal to 3 and less than or equal to 8. So we can write it as one inequality. Notice we have two closed circles here. A closed circle at 3 because 3 is included. We had the word inclusive. A closed circle at 8. 8 is also included, and we know that because of our inequality symbols have the or equal to line underneath them. And then we're shading all the numbers in between 3 and 8 because all of those numbers are included as part of this inequality or verbal description. The next one, all numbers less than 5 or all numbers greater than 10. So think of a few numbers less than 5. -2, 0, 3, and 4. Think about numbers greater than 10. 10.5, 11, 28, 52. So the way to write this inequality, x is less than 5, that's all numbers less than 5, or x is greater than 10, all numbers greater than 10. That's the only way to write this inequality. I cannot put it together like I did for you in the first row, so leave them separate. X is less than 5 or x is greater than 10. So we know that we're going to have two open circles here. The first open circle is at 5. And I need numbers less than 5, so we're shading towards our 3 and 4. Then I need another open circle at 10. And we need all numbers greater than that, so we're shading to the right towards 11, 12. The next row, all numbers greater than 1 and, that word is important, less than or equal to 4. So pause the video and I want you to think of a number greater than -1 and less than or equal to 4. Zero, 1, 2, 3, 4. You could have a decimal, 0.25. So let's write this as a compound inequality, and I'm going to show you how to write it both ways. So first, let's focus on all numbers greater than -1 and all numbers less than or equal to 4. That's how we write it using the word and. And now let's write it as one compound inequality. So x was greater than -1, so we're eating the x. But x is less than or equal to 4, so this inequality symbol is eating the 4. Think about your Pac-Man mouth or your alligator mouth. Okay, let's draw a simple number line here. And we are going to graph this. So I need my open circle at -1. And x values are greater than that, so we would be shading to the right for greater than. And I need a circle at 4. And I can be equal to it. I can include it, so fill in your circle or close it. And I need all x values less than that. So I would shade to the left. So really, we're shading in the middle of these 2 points to connect them. All numbers less than or equal to 3 or greater than 6. So give me a number less than or equal to 3. 3, 2, 1, -6. Give me a number greater than 6. 7, 9, 10. Because we have the word or here, I know I need the word or in my answer. So all numbers less than or equal to 3 or all numbers greater than 6. So 2 inequalities. Draw your number line. X is less than or equal to 3, so we're going to put our circle on 3, or equal to, so close it, fill it in. And we're shading towards the left because we're less than that. Our next circle is at 6, and we're going to leave it open because we're greater than 6. 6 is not included. And greater than that, we shade towards 7, 8, 9. So what I would like you to do is pause the video and answer question 2. Compare and contrast the graphs for conjunctions and disjunctions. Ooh, those are new vocab words. Conjunctions and disjunctions. So what we're going to do here is I'm going to go up and label which one is which for you. This right here is considered a conjunction because we use the word and we're shaded to where they connect. This is a disjunction because we use the word or and we shade it apart. They're disconnected. Conjunction, disjunction. So go ahead and fill in what you can notice about similarities and differences for question 2. A similarity is we have graphs or number lines. And they show a range of numbers or answers on the number line. They both have shading. Good. They both have 2 circles or 2 points. What about a difference? The conjunctions, which is the and statement, shade together, or they shade in the middle. There's only one line segment on our graph. The disjunctions, which is the or statements, they are shaded apart or opposite directions. So there are 2 rays, 2 shaded areas going apart. Some circles are open, some circles are closed. That's another difference. One uses the word and, another uses the word or. Go ahead and turn your page to 44. And we have Spartan Middle School. We talked about them already before. And they are doing the mile run, push-ups, and modified pull-ups. Okay, so if we're going to look at this example together, let's take a look at the push-up range for 12-year-old boys. So push-ups, boys, 12 years old is right here in this box. It says step 1, choose a variable. Let P represent the number of push-ups. So we're using a P. Our push-ups need to be between 10 and 20. Okay, so P has to be greater than or equal to 10, and P has to be less than or equal to 20. So everything between 10 and 20 is included. So let's write this as one big inequality like they did below. So notice our P goes in the middle, our variable goes in the middle. Our low numbers here on the left, that's 10. Our high numbers on the right, which is 20. And then we have 2 inequality symbols. Notice both inequality symbols face the same direction. This is saying that my push-ups have to be between 10 and 20, and those 2 numbers are included. So push-ups are greater than or equal to 10, less than or equal to 20. So we're going to put whole number dots because we count push-ups in whole numbers, 10, 11, 12, and so on, all the way up to 20, and then we're going to stop. We would not shade here because we can't do 11.2, 13.5, or 16.8 push-ups. That doesn't make sense. So take a look at the Try These A. I'm going to help you through some of these, and then I want you to try some on your own. You have the table directly above you on this sheet, but I wrote in the push-up range because my table is on the last slide. So the push-up range for 13-year-old boys is 12 to 25. A range of values. 12 is the lowest. 25 is my highest. So I know that this is a conjunction. We're going to write it as one big statement. Should we use a P again for push-up? Our push-ups have to be greater than or equal to 12. And our push-ups have to be less than or equal to 25. So this is a conjunction, one big compound inequality. And instead of using the word and, we're just going to write it together. Now, you have to draw your own number line. So we would go from 12 all the way up to 25. And I'm not going to be extremely specific or accurate here. But how would we graph this? We would need to make sure that we have whole number dots. So points at 12, 13, all the way up to 25. And we can stop. Question B, the pull-up range for 13-year-old girls. So look up in your table. Pull-up range for 13-year-old girls. It's a range of values from 4 to 13 and everything in between. So the lowest number that we can get is 4. Our highest number is 13. They don't tell us which variable, so let's just use a P for pull-ups. Our pull-ups have to be greater than or equal to 4, less than or equal to 13. And everything in between. So again, pause if you need to draw your number line. 4 could be an option, 5, 6, all the way up to 13. We count push-ups and pull-ups in whole numbers, so make sure you're using points, closed circles, and not shading. This again was considered a conjunction. We use the word and, or we write it as one big compound inequality. So our mile time for 12-year-old girls. The mile time. They could be from 9 minutes all the way up to 12 minutes and everything in between. So our lowest possibility is 9 minutes. Our highest possibility is 12 minutes. I'm going to use an M for mile. You could use an R for run. So our mile time has to be greater than or equal to 9, but less than or equal to 12. Hopefully you're starting to recognize a pattern between all of these. So we have a closed circle at 9, a closed circle at 12. We could get 9 minutes and 13 seconds or 10 minutes and 35 seconds. So we are actually going to shade this time. When we count a mile time run, it's continuous. What about the mile time for 13-year-old boys? Anywhere from 7 minutes and 30 seconds all the way up to 10 minutes. So 7 minutes and 30 seconds is like 7.5, 7.5. Our highest is 10. Use an M again for mile. Our mile time has to be greater than or equal, so make sure your alligator mouth, your symbol is eating the M. But it has to be less than or equal to 10. So closed circle at 7 minutes, 30 seconds. A closed circle at 10. And we are going to shade or fill in everything in between that. Because we could get 8 minutes. We could get 8 minutes and 52 seconds. So shade in between. This again is a conjunction. It's one big compound inequality. Notice we're shading to connect our two circles, our 2 points. Question E. Ooh, this one's different here. It says a score outside the healthy fitness zone for girls push-ups. So look at girls push-ups. The range is from 7 to 15. That's considered a healthy fitness zone. But we want outside of that. So we want our max values or our push-ups, so let's use a P, less than 7. Do not put an equal to line under there because 7 is included and we want outside of the healthy fitness zone. So anything less than 7, 6, 5, 4, or any amount of push-ups that's greater than 15. Again, do not include 15 because that's in the fitness zone. So do not put an equal to line under there. So because I have the word or, and I have two separate compound inequalities here, this is called a disjunction because we use the word or. So if I was to graph this, seven doesn't work. 7's not included. Does 6 work? Yes, so let's put a filled in circle at 6, a filled in circle at 5. If I could fit 4 up here and 3, 2, 1, 0, we would do that. Not a circle at 15, but I can do one at 16, and let's pretend this is 17 right here. We can do 17 as well. 18, 19. Those are considered outside of our healthy fitness zone, so make sure they have points that are closed, that are filled in. This is a disjunction. We're disconnected. We're going apart. We're going opposite directions. So, question 3. Why are individual points used in the graph? For example, A. You can go ahead and write this down. We're using individual points because push-ups and pull-ups are counted as whole numbers. Students can't count part or half of a push-up or pull-up, so we need whole numbers. Now, the mile time we actually shaded because time is continuous and we can count all of those. When we get into examples, math examples of how to solve these, we do not have to focus so much on do I do whole number dots, do I do points, or can I shade? So when we get into it, all of them are going to be shaded unless we're given another story problem.